Alrighty, so welcome everyone to the Karpenter Working Group for June 6th. Starting or go ahead and share screen first. Okay, so yeah, starting with the project updates. So the main one we have is Karpenter v37 was released. For the AWS provider, at the very least, the major callouts here are we now support EKS 130 and Kubernetes 130. Along with that, there's support for the zone ID label that was added to CCM for Kubernetes 130. And so, yeah, those are the major callouts. It's a pretty big release with a lot of smaller housekeeping related changes. So definitely make sure to check out the release notes if you're interested. And yeah, I think that's about all I've got for 37 release, unless anyone else wants to add anything. Bryce, I'll let you take it away.
Similar case here. We haven't quite upgraded to V37 yet, but we have the 1.30 pieces we need for AKS 1.30 support. We fixed a couple of bugs with GPUs and some of these things. It's a minor release, nothing too crazy going on, but there should be some minimal improvements. That's all.
All right, nice, thank you. Any other project updates we want to add before moving on to the RFC section? All right. Well, moving on then. I guess throw this over to Nick on making expiration forceful. I can't hear you. I don't know about anyone else.
No,
Can't hear him. Nope.
How about now? We good?
Now we can.
Perfect. Yeah. Thanks. So cut this RC so that please let me know what you think. So basically, I'm not sure why the images aren't working, but I'll fix that. So basically, when we first made expiration a bit ago, it was effectively as soon as the node was expired, we would delete the node and then we'd we'd spin up nodes in response to the pods that get evicted. So there's some problems with that in that there is some people didn't like how, if you have a big scale up, then all the nodes come up and then at the time that they all expire at the same time. And so there was no jitter, and then this would cause a bunch of workload disruption if you didn't have your PDB set up correctly. And so we made this graceful, I think some time ago, like maybe 2 years ago, a year or two ago. And one thing that we realized is that for the cases of termination grace period and some other cluster admins where like you might want to enforce a maximum node lifetime, is that maximum node lifetime when expiration is graceful is blocked by no disruption budgets. It's blocked by do not disrupt or PDBs. And it's also blocked by if you're able to have able to pre-spin replacement capacity. And so one thing we realized is that the way that we've kind of thought about expiration and like its use cases is like something that usually goes along with like compliance with like maybe like a security team wants you to not have a node up for a certain amount of time. And it just wants to refresh it so that there's like, CVEs like periodically updated and such. We realized that if you have these blocking conditions, then you basically as an app developer can prevent this node from ever expiring, which is kind of against probably what the cluster admin wants. And I think that if you wanted to like upgrade things, then that'd be better encapsulated by drift. So in this RSC, I'm proposing that we make expiration forceful again. So what this is basically as soon as the node is expired, we'll delete the node and we'll still respect PDBs and do not disrupt as part of the like graceful termination of the node. And once we have termination grace period seconds in, it will gracefully terminate for as long as that termination grace period is not out of, like how you haven't reached the period yet. And then once it hits that termination grace period, then it'll forcibly clean up. Are there any questions? Might just be worth reading. Yeah.
Yeah, I see Garvin. You have your hand raised.
Yeah, sorry, I wasn't keeping track of some of the stuff. Like, did we merge Matt's changes for the Grace?
Not
I
yet.
forgot what the name is called. Okay,
Not
how's
yet.
that different from this? Like, it feels similar, or it can ride on
I-
the coattails of this.
I think that my PR is actually implementing this design, maybe. And we're
Yeah,
gonna
that's
talk
why I
about it
was.
tomorrow. Yeah.
Yeah, okay, because I was like,
Yeah.
oh, it feels very similar, so I wasn't
Mhm.
sure if I was missing something.
Jason,
So this,
do you
oh,
mind scrolling down to the diagram below?
yeah, sure. Which one do you want?
The
Forceful expiration?
I don't know if you can zoom
I don't
in.
know if there's a way for me to zoom in on it. Yeah.
If
Maybe.
you click like Command plus or I don't know,
Yeah, just
You can
the
click on view
shitty
file, click on the dots and click on view file.
or that, yeah.
oh yeah, that'll probably do it. Oh, yeah, now that looks good.
Click on this.
So
Okay. Yeah, so the highlight here is that right now the expiration is packaged with where drift, underutilization, and emptiness are, which is it nominates it like groups together like conditions that it can find on the node claim, and then it will nominate it for a disruption command for step 2 to 3. That once it has the ability to know that it can gracefully terminate it and it has NDBs not blocking and no PDBs blocking and so on. The proposal is to make it so that as soon as a node is expired, which is expire after on the node pool, we'll just immediately kubectl delete the node to make it go from like, so it won't like wait for pre-spun capacity, and it won't wait for NDBs to not be blocking, and it'll just start draining any pods that can be drained, but not draining pods that are blocked by PDBs or do not disrupt.
Oh, I see. Okay, it's short circuiting the nomination and straight into, okay, I'm going to start draining, but it won't create a node first. It'll just start draining and
So,
then
yeah.
hope that the pending pods will create a new node.
Yeah, so our provisioning controller will respond to nodes that are deleted. So as soon as we delete that node, we'll actually start like doing the scheduling simulations to create the node for the pods that we know are going to be drained. The termination grace period will kick in as soon as we get to step 4, basically. And you'll see that like on like the 4 to 5, you'll see the termination grace period is over. That's like that period, and then forcibly terminating is like deleting the EC2 instance and deleting the pods directly.
Is this proposing any difference in behavior between a node pool that has termination grace period versus one that doesn't? Or would this work the same way in both cases?
So I think that's the difference of like a graceful versus like what we called eventual.
Mhm.
And my thought was that since the idea, this is kind of like a question and an answer of like, my thought is that if we make expiration forceful, then that's like, a step further than eventual.
Yes.
But the only reason why I would think we would need any other eventual type of thing is if we thought that drift needed to be eventual.
Okay, I guess, does this proposal have a preference on, so if I don't have a termination grace period set at all, can a user with just a bunch of do not disrupt pods block expiration in this design or not?
Yes.
Okay,
So
it's
well,
still eventual.
block expiration, like in
Yeah.
that we'll still delete the node, but it
Mhm.
will prevent it from being ever like eventually cleaned up. Yes.
Gotcha. And so effectively, termination grace period is the option to use if you want to opt out of eventual and ensure and like have a hard enforcement on there being on expire after.
yeah, I think the other difference from like the current implementation and what we had like proposed with the work you're doing in your PR for termination grace period is that regardless of whether or not termination grace period is set, as soon as a node is expired, it is going to immediately be deleted. And so once like that deletion timestamp is set, the termination flow kicks off. you're going to have this pot node draining. With termination grace period, that's bounded. Without termination grace period, that could potentially be unbounded.
So I don't expect everyone to have all the details fully consumed right now. So just wanted to call out that this is an RFC. If you have any thoughts about this, if you really just hate the idea of forceful expiration, please let me know. If graceful expiration never made sense to you, please let me know too. Yeah, just let me know. I don't want to take up the whole time, and I think it's better if we just continue on. So
Okay. Yeah, unless there's anything else, we can go ahead and move on to the next RFC. Okay, so that would be ODCR support.
Yeah. Well, yeah, so Thorben, Garvin, me, I think also Nick have been like discussing a lot with so Garvin originally opened this proposal for supporting ODCRs in Karpenter, specifically in AWS provider. And then Thorben has kind of since added a bunch of additional work on top of that and done like a POC implementation of this based on the initial RFC. So if you haven't had a chance to take a look at this, please do take a look. So I think the main things that we are looking to get feedback on have to do with the API, which I think we kind of are all agreed that we can perhaps scope down like a good portion of this API down like with some of the selection mechanisms. So maybe like basically, if you're not familiar with how capacity reservations work, it's basically OD, but you can pre-reserve it, and then you select, like you basically prepay for a set of capacity, and then you're able to launch into that capacity reservation. Generally with EC2, Karpenter today doesn't reason about this. Like you could get into a capacity reservation by happenstance, because there's basically a concept of something called an open capacity reservation, where you can create a capacity reservation, and if it just so happens that the instance type and the AZ that you launch matches that capacity reservation, then you will actually, like by launching OD capacity, you'll use up that capacity reservation. But this is also proposing that we support both OD, where we like specifically know that we want to use OD, like Karpenter is aware of the fact, or sorry, OD, open, where it's aware of the fact that it wants to use like open capacity and like kind of target it sort of, as well as support what's called targeted capacity reservations, which is where you like directly specify an ID and you can't otherwise like launch into a ODCR that is targeted without directly specifying the ID. So it's like if you wanted to specifically reserve some capacity for like your AI ML workload jobs, and you have like super big instance types that have big GPUs, you might want to isolate those to specific teams, and therefore you'd only want to specify those as targeted and not have people just like arbitrarily matching them across all the clusters in their account potentially. I'll stop there. I don't know if Thorben, Garvin, if you want to add any more color to like that overview. Okay, so with that, we want to make Karpenter aware of capacity reservations so that it can know that it should launch into those, and ideally launch into those first ahead of other types of capacity, because those capacity, like the capacity is already paid for, and it most likely is being considered for availability reasons. So we want it to kind of be prioritized in front of maybe standard OD capacity or spot capacity. And so the idea here, if you scroll up a little bit, Jason, is we can specify a capacity reservation selection mechanism on the EC2 node class that would allow you to basically say, okay, I want these capacity reservations, and you can select a set of capacity reservations, like you could select a set of AMIs or select a set of subnets. I think we can, like I'd mentioned at the beginning, I think we can perhaps scope down the proposed API here a little bit. Perhaps just ID tags is enough, or maybe there's some other selection mechanism that we're kind of thinking about and talking about within the context of the RFC. But regardless, there's some set of fields you can use to select on a larger set of capacity reservations. Those are now tied to the node pools that link out to the EC2 node classes that rough out to it. And as a result, what we're thinking is that basically becomes an additional offering on top of a given instance type that Karpenter would discover. So if you select on a set of instance types inside of your node pool and you have a capacity reservation selector, you could then, like anything that capacity reservation selects against, the selector term selects against, would basically hydrate additional offerings onto your instance type options. so that now you have an additional option, which is a capacity reservation offering beyond like on demand and spot. And that capacity reservation offering has like potentially a substantially lower price, or price effectively zero, because you've already prepaid for it and you want to prioritize it. So the idea would basically be you can select on them, and then Karpenter reconciles those capacity reservation selector terms, and then is able to then hydrate potentially some capacity reservations into the status. It uses those capacity reservation terms to select additional offerings and then use that for scheduling. It potentially is also aware of the number of like capacity reservations have availability. So it's potentially aware in the scheduler of how much availability exists on a given instance type, so that when it's scheduling pods, it knows not to like overschedule too many to a given capacity reservation, because it may not have, like, it may be limited to like 2 nodes and you needed 4 for all your pods to schedule, and that won't succeed. So it needs to know like how much capacity it has. So that's kind of the working idea, but there's like a host of questions around it. And I think we mainly want to like get feedback on some like high level use cases. So, and this is where like Thorben and Garvin, you guys can add additional color as well. But one of the high level questions we'd originally come at this with thinking about just like targeted ODCRs. I think after some discussion, both on like the AWS side and also just generally in the community, it makes like there's a lot of people that use open ODCRs, and like just by nature of the organization. I can't remember historically if targeted came after or not, but anyway, I think historically there are a lot of people that use open ODCRs, and so I think we do want to scope in open ODCRs into this kind of ODCR selection mechanism. So you can imagine like Karpenter could, on top of discovering ODCRs by ID or by tags, they could discover like all open ODCRs. So you could like say, you know, I don't know, type open or targeted. And then if you specify type open, then you get like Karpenter sees all of the open ODCRs and then knows to prioritize them for capacity. That's one option. So I think that's like we're pretty convinced of. I think the difficult pieces that, well, okay, so there's that. One of the difficult design questions that we're running into here is that like ODCRs in general can have an expiration time. And what that means is that you can launch into an ODCR, or they can also be canceled like manually. You can launch into an ODCR, the instance can be part of an ODCR, and then after some amount of time, it's no longer part of an ODCR because you canceled it, or because it gets expired because you specified a time at which it should no longer exist. And so that ODCR capacity, like from EC2's perspective, like all this capacity is on demand, whether it's in a capacity reservation or not. It's all on demand capacity from like a usage class perspective is how they frame it. And so it being converted from like in an ODCR to not an ODCR is a little bit of like a pricing construct combined with like an availability construct, where it's like they could potentially interrupt, or not interrupt, but they could like, there could be like a maintenance event and like you could lose your OD capacity or something somewhere down the line, something like that. And you're not necessarily guaranteed to keep it. So the question is, on Karpenter's side, if the ODCR gets expired, like the way that we were originally thinking about this is that you could basically specify like a capacity type reservation as like an additional, like you have
If you
spot.
can scroll down a little bit.
Yeah. You have like spot, you have on demand, and you have like capacity reservation, capacity type. And so what that would mean is that from an application owner side, you could say, I want to, well, I guess there's some issues with this, but like theoretically, you could say from an application owner side, I want to be in a capacity reservation. And then like Karpenter would just do all of its natural scheduling mechanisms with this. And then the node, when it launches, would have the capacity type set to capacity reservation, and everything would just schedule as normal, and that's all great and good. The problem is when the ODCR expires, what do you do? And this is kind of like the open question we're trying to get a use case feel on, is like, what do people want to have happen when ODCRs expire? Because there's some like technical complications with that ODCR, like that on-demand capacity no longer existing inside of an ODCR from like a price modeling perspective, and also from like a selection perspective. Like basically, if you allow, like if you have a capacity type capacity reservation and you allow application owners to select on it, once that node no longer exists in an ODCR, do you drift that node? Because the trade-off here is basically like, if you like one of the use cases that Thorben was kind of bringing up, and I think Arvin as well, was like, well, the ODCR is expired, but I still want the on-demand capacity to stick around because like realistically, I'm like maybe doing this for like a migration or something, and like like relaunching the capacity makes no sense because it's gonna just come back with on-demand capacity anyway theoretically, and so you're not really gaining anything by having to like drift and do a relaunch other than the labeling semantic. And so, but the problem is if we support that, now you can't have like this capacity type selection mechanism because it's changed. So we're kind of running into a bit of a wall here with like, okay, I have to somehow model something that like is and isn't at a given point in time, but I also don't want to drift it. So it's like it is on like it's perhaps the way we're thinking about it is like it always is on-demand capacity.
But I want to drift it, right? If my node pool doesn't have on demand in it.
Right.
If you
Right.
drift it, you might lose it.
But if it's, yeah, you might lose, yes. Or yeah, yes, if my node pool only contains capacity reservation, yes, it would be drifted and it would be removed, but a Karpenter would bring up a new instance probably before it would terminate the old one.
Probably, but not guaranteed. And if we're talking about capacity reservations, these are the node types that are the ones that are in demand and we're not able to get reliably, else we wouldn't really be caring about capacity reservations in the first place.
I guess the only scenario,
yes.
so you don't necessarily lose it, right? Like the situation only happens when you already lost it in the capacity reservation. But then I guess the question boils down to, is there a use case where an application can only run on capacity reservation, nothing else, and it cannot fall back to on demand? Because I think like that's, I guess, the question that we kind of have is like, do you ever want an application to fall out of ODCR? Because let's say
Yeah,
something
to not
expired,
run.
yeah, to never run outside of ODCR, which
We've
it sounds
used some capacity
abnormal.
reservations and
Right.
that would never come up for us.
Yeah,
The cases
I
that
was
we're
thinking, yeah.
using them for are because we want to specialize in so that are not
Yeah,
reliably available usually.
Right. That's exactly our use case. Is like, oh, we want it to be there, and if there's on demand, that's fine too. So we want to see like anyone else has this kind of situation where it's like you can
Well,
only
you would
run.
always define the bottom one here, where you have in the capacity type, you have both. You have capacity reservation plus on demand.
Yeah,
Yeah.
great.
And-
I think use the second one that perfectly makes sense and solve all these our requirements. And the first one, if kind of you only select capacity reservation, then once it's expired, I think the semantics wise, it's better to just doing the drift to replace them with on demand.
That's an interesting question. So like I think Brian's raising this as well. I actually don't know, like I don't have like super deep knowledge on how ODCRs handle like expiration. Like if your ODCR expires, like it's OD capacity, right? So I think Brian, you said like you're not able to like keep the capacity for some reason. But how does that happen?
No, meaning if the drift happens and the node gets terminated and it brings up a new one, that new node maybe never comes up because it's never able to bring up an on-demand instance or like a,
Yeah.
like,
Right. But if you expire the
No,
ODCR,
yeah. What happened to the expired node? The node that has expired ODCR, does that get reaped? I don't think so, right? That's still yours,
no, it doesn't,
right?
no, it's yours until you terminate it.
Right. I guess the question then is like,
He's talking about like using like expire after or something like that. Like if the ODCR goes away and then you still have this instance,
Yes.
and then it gets drift replaced or it gets expired or something else happens, it explodes on AWS, then it's just gone. And you may never get it back, right?
Correct,
Yeah.
but that seems to be like a mismanagement of your ODCR in the first place.
Yeah, well, yeah, I don't disagree with that. But it's a little bit, it's a weird case. But also, like, it's possible to solve the case that Jonathan's talking about just by using affinity instead of using node selectors directly, right? Like, you could use an affinity selector that
Well-
allows both on-demand and capacity reservation capacity types.
Well, the question that Jonathan is asking is, we shouldn't be, like, if a label is changing, we shouldn't be using or allowing it being used in a selector or in an affinity.
Oh,
Right?
you're saying
I
that
think
there's,
there's like two, like the idea is that from a developer perspective, I'm deploying my application. I don't care
Yeah.
about capacity reservation. I should care about on-demand and spot. Right? I should be like, oh, I want to run it on demand or I want to run on spot, or I don't want to run on spot, right? Like I should be able to say these things. I should not be knowing about capacity reservation. Capacity reservation is kind of a, I manage the cluster and I define the node pools and EC2 node classes, and I manage the cluster and I define all of these things. But from an application perspective, they shouldn't be caring about capacity reservation.
Yeah, I guess that's the question. Like, do
Yeah.
That's one of the
users
questions.
care? The application? Okay,
Yep.
sorry, go for it.
Yeah.
Do they
This is a
care?
really-
If they don't, this doesn't matter as much, and we won't drift it. We don't necessarily drift it. But if they do care, then we might have to, right?
Yeah, this label feels like a weird catch-all right now. If we start introducing like capacity reservation into it, things start to get a little weird about like, what is this label for?
Yeah,
It's
so
so nice.
there's like two problems with
Yeah.
this. Like one is the question that Garvin just raised, which is, okay, do we even need it? Like, do we need the
Yeah.
ability for application owners to be able to select on this?
Mhm.
And the answer is no. Then there's perhaps like this is like a nicety from like a admin perspective being able to specify it, because it kind of works nicely with the existing API, but it perhaps creates additional like weird edge like side effects because it now allows application owners to be able to specify. So
Yeah.
are there other ways in the API that we can allow like users to be able to set? Because basically the use case we're trying to meet here, or as I understand it, is that like I also want to be able to say only give me ODCRs, don't give me OD fallback. So
Is it because there's different pricing with the reservations, or like, because my understanding was that they were effectively just on-demand instances, like through and through. There's no difference.
Correct. The main reason is the use case
Availability.
for us. Oh, sorry, what is it?
Sorry, go for it. Sorry, go for it.
Oh, the use case is that you can use ODCRs effectively as capacity management. And if you don't want to spin up additional instances, you can say the ODCR has 10 instances. If you want to try to bring up an
Yeah.
11 one, you don't get it,
I see.
right? Because we
Okay.
have a fixed budget for the month and we calculate if we use this instance type, we're going to spend X amount and we don't want to go
Yeah.
over that budget.
Yeah, for us, we're never super worried about that, but that does make sense. If like you have some kind of central platform team that's saying like, okay, you get up to this many instances, like that's all or whatever. That kind, yeah. It seems that's one way to do it, I guess. I don't know if there's better ways, but yeah. But I think it is still
It would be an
supported,
easy way
yeah.
for us to do it, right? Doesn't mean that that's necessarily the way we implement it, right?
Yeah.
If that's like the only drawback, right? But that's kind of the use case that we have.
yeah, because the other option here is like you literally just don't allow selection and you don't.
Well, you could fix it by doing a math calculation on the number of CPU cores, right? Like if you do max,
Yeah, you could do like limits or something like that if you wanted.
Yes, you could use the limit times the instance type, right? And then make sure
Yeah,
that
my point was
doesn't
like
run
if you
over.
don't have to meet this use case of like just thinking of OD and ODCRs as different, then you can kind of just like get it for free in some ways, because you just hydrate the offerings after you do the capacity reservation selection, and then you just know to pick them as long as they're available.
Yep.
Otherwise you pick like spot, and then otherwise if you wanted spot, and otherwise you pick OD. And then you don't have to deal with the ODCR going away problem, because you just recognize that once the ODCR, like once an OD instance is no longer an ODCR, it's just modeled differently from like a pricing and prioritization perspective. So, I mean, it does make things easier in a lot of ways to not have to meet that use case. But if we think it's, yeah, it's kind of a trade-off between which use cases we think are valuable to meet with this particular design. Yeah, and you could also drift it, but if we want to meet the use case around like being
That's
able
only,
to
yeah.
go from ODCR to OD, then yeah.
Yeah. Yeah, if we don't have this label on the node in the first place, then a lot of things get simple.
In my mind, we can add it later and not add it now, because there's nothing stopping us. It's not like a one-way door where this cannot be implemented after the fact if someone needs it, because it's additive, I believe.
Yeah.
So in which case we can just say, don't do it now until
It's just
people
yeah,
actually wants it.
it is an on-demand instance though. It's an on-demand capacity
Yes.
reservation. So
Yes.
it's weird to call it not an on-demand instance on the labels.
Agreed. It is. Agreed. 100% agreed.
Corbin, what's your perspective on it? Because you were originally thinking this was a use case you needed.
That was the easiest. I feel like this from a admin perspective, this is the best way to implement it, right? Like coming from a cluster administrator, coming from a developer perspective, yeah, I think you're absolutely right. It makes sense, right? To not have it because I don't want to introduce that to my developers, right? And we actually have this use case because we have the use case where people just want to run it on demand. They don't want to run on spot, right? They want to guarantee that they don't run on spot. So yeah, and then we would need to tell them that they need to add the capacity reservation, otherwise, yeah, which is kind of an overhead. Yeah, the question is, what would we do? We would just make it based on if the instance has a capacity reservation label, has a capacity reservation ID label or annotation. Sorry, capacity reservation.
You do like
ID.
like if you wanted to create non-structured data, like basically we're talking about like a property bag to some degree to keep track of the ID so that we know like whether it is or isn't like doesn't exist. Or I guess you could really, I mean, you could do it a few ways. You could model it on the node, or you could like just directly look it up at EC2. Like either one's fine. You just need to know like whether it is or isn't in a reservation. Probably makes sense to model it on an
I mean,
annotation.
it would be nice, in my opinion, if you do a get node claims dash row wide and you see on demand and you see the capacity reservation ID or something next to it. So
I
you
think,
can,
yeah,
you can see out of that return, like, am I running all capacity reservation or not? I might not have the on demand flag, but at least as an administrator, I can easily see, right, if someone says,
I think you're right that, I mean, even more than that, like from a modeling perspective, we kind of have to look this details up like in cluster. So we need like some way to reconcile it on and then like compare it as we're doing like consolidation decision making, particularly is how I'm thinking about it.
and then in order to match the use case of, was that something that we want to do later, phase 2, or was that something where, but the capacity reservation, only being able to spin up capacity reservations, like it just like Karpenter not bringing up on demand, would that be, yeah,
Yeah, I mean,
is
it is
that
additive. I know
that would like it be an additional feature. You could be able to have a workaround where you calculate it based on the limits.
yeah, well, I guess that's a little tricky, right? Because like if the ODCR is filled up, then like you basically would have to isolate an ODCR for that case to be met, which maybe you are if you're doing that. I guess the use case is kind of implying you are. Because otherwise you just get on-demand capacity. Like we're giving up a couple of use cases by doing this. We're giving up the use case for just selecting an ODCR, and we're giving up the use case for opting in to
Only ODCR.
well, that was the first one,
Yeah.
and then you
Oh, yeah. So,
like opting into what would it be? It would be opting into some ODCRs, but then specifying a larger set. I guess this is probably a crazy, like you probably just need to create multiple node pools if you're doing this. Like you have some larger set of instance types and you only have a subset of them that are in ODCRs, and you don't want the rest of them to also, and you're doing spot and OD. And you want these available for spot and just these for ODCRs, and you don't want everything for on demand. But that seems kind of insane to me.
Or you would pick the ODCRs based on instance types, that would be preferred. And then it would, oh, you mean you cannot use something for spot that you don't normally use
You can't
for
opt out of on
on
demand.
demand.
Like that's the key problem here is like you can't.
Well, then you would, yeah, but yeah, okay. I would argue if you have multiple instance types for different use cases, for different capacity types, you always do different node pools.
Yeah, it's more like you're going to select like in that node pool. You can't fall back to another node pool by not getting ODCR. Like it's the
I mean,
same.
it's a similar use case today, right? I cannot do on demand for a specific instance type plus spot for a different instance type at the same time. I would need to create 2 node pools.
Well, it's more like no, you can do it, right? I mean, I think this is like such an edge case though. Like, well, I'm saying like, sorry, maybe I'm not following what you're saying, but
That's okay.
yeah. I think what I was saying was like you've got some set of instance type, like you want within a single node pool. Like I want all these instance types available for spot, and I want this subset to try ODCR, and I don't want on demand and fallback at the end if none of those.
Oh, you only want spot or capacity reservation.
Yeah, which is kind of
Yes.
also crazy, I
Yeah.
think. But okay, so I think we have good direction here. I think that the other one that we wanted to just like briefly touch on, which is a bit easier, is capacity reservation group usage.
Oh
like
yeah.
resource groups. Trying to get a feeler on like I think we originally thought, okay, maybe we don't want to do this, added some complexity. I don't think it adds that much complexity, like thinking about it more.
Depends on how you want to implement it.
But I guess
But
we can
if we are currently not supporting the use case of fallback to on-demand is not allowed, then capacity reservation groups do exactly that, right? Like there were because the difference is that capacity reservation groups, you send something, and if it's not available in the reservation, it falls back to on-demand immediately. With if you use just capacity reservation, Karpenter has a little bit more control of saying, no, yeah, I can make another decision if capacity reservations are not available.
It's just one step to get there though, right? Because like you don't have to send the capacity reservation group to fleet. You could just look up the capacity reservations in the capacity reservation group and then just like understand that and then still send the individual capacity reservations to fleet.
That's the question. Like that's what was my question that you pinged me about. When we talk about capacity reservation groups, do you want to put the capacity reservation group into the create fleet API, or do you just want the groups to be able to select something additionally to put it as a list of capacity reservations?
I think we can perhaps like figure out, I don't want to get like way too deep into the weeds because I do want to get like feedback on, do we want to support capacity reservation groups in general? But, and like, if we decide that, then we can figure out like what I think the answer, I don't know, I'll hear from other people that aren't involved in the design. If anyone has thoughts.
What you mean by the capacity reservation groups, that's the ability to attach multiple reservation IDs to a node pool, correct?
Well, that's already existing. That already you can do. But what you cannot do, like currently maybe someone, like the use case is something like this, you have a capacity reservation group that you created that you use with an autoscaling group, because autoscaling group only understands capacity reservation groups, but you want to use the same capacity reservation group inside of Karpenter as well, so you don't have to manage it differently, or like, hey, this is my set of capacity reservations that I have available, right? So you can use the same concept for autoscaling group and for Karpenter at the same time.
You want to,
I think in general, I think I agree to support it. I feel like the easiest way to would support it to just use it as a wrapper for finding them and use them the same way that you use the existing capacity reservations, and not have them as two different code passes when Karpenter does its evaluation.
I guess one use case that I've seen reservation group used for is like, because you can group capacity reservation together, you can cover all the availability tiers, whereas each capacity reservations one availability, one availability zone. So if you have 3 zones, I'll make a group 3 zones and I'll use that. At least that's the most common use case I've seen.
Yeah, I think Thorben's point is like you can do that with like Karpenter's kind of creating the concept of a capacity reservation group at the node pool level. The only benefit you get from like being able to select on capacity reservation groups with this API is the ability to have a single pane of glass for managing capacity reservations. And that's
because currently capacity reservation selector terms finds all of them, right? If you use a tag, and you have 3 with the tag, it uses all 3 and then hopefully across all the AZs, right? So you can, like, Karpenter doesn't just find one capacity reservation for one node pool. You can have as many as you want within one node pool. Well, one EC2 node class. Like it's basically grouping them together already inside of the EC2 node class. The difference is that you manage them differently, right? That's the main difference. Yeah. I think we should support it. I think we should at least support it in the same way that we support it for the regular capacity reservations, but it makes it easier for someone to use autoscaling groups and Karpenter at the same time, and don't have to worry about like use the same concept or like the same entry point. And it's not that hard to implement. I think as long as we're not treating them differently, we're just using the group as to how to find the capacity reservations.
I think I don't want to. We've taken up quite a bit of time on this discussion. I think it was good though. I want to move on so we can hit the other items that are on the agenda too.
Yeah, so we've got the provisioning request, headroom RFC, and then a few community questions. Got about 17 minutes left.
Yeah.
So yeah, let's
Just be really quick. We won't cover
Alright.
it in its entirety because it's still in draft. And I should probably also indicate that it's in draft. Basically, we had some of the Karpenter maintainers had a discussion with some of the Cluster Autoscaler folks, and we also have thought about a little bit about the ideas around static capacity provisioning and just like headroom on deployments in general. We've had some conversations in working group on this previously. There's some open issues which I'm planning on linking in this talk, but haven't yet. Around people wanting to be able to do this. So I'm putting this doc together basically because Cluster Autoscaler came out with the concept of a provisioning request API back in September of last year, and it's integrated with Q, which is like a job scheduling framework for AIML. Well, it's job scheduling framework generally, but it's mainly for AIML workloads. And the idea behind it being basically the use cases we're talking about, where you could, I think the main one they're trying to hit is atomic scheduling of a set of pods ahead of time. So they have a concept of pod sets and this provisioning request API. And you can basically say, okay, for this representation of pods, I want you to pre-provision capacity for me without having to create these balloon pods, these negative priority pods. So I create a separate API concept, and I get atomic scale up of that thing and ensure that it exists ahead of actually deploying the job itself and doing the atomic scheduling and that kind of thing. So that was the original intent behind the API. We've done a little bit of thinking around it as well, and I think want to kind of propose a slightly different API, but something that is similar and meets a lot of the similar use cases and perhaps extends off of it. So anyway, we're putting this together. There's going to be some discussion on API and some of the contention points we have between our thinking around headroom and their thinking around provisioning request. We're hoping to the end goal, which is kind of what we kind of intended when we originally joined the SIG, was we want to kind of create a standard and align on that standard in the SIG. So for just generally for Kubernetes. And so we're trying to they created this thing a while ago. We have kind of more recently thought about it and given more feedback on it. We're trying to kind of align towards a common solution that we can create as a standard for everybody. So anyway, this is, like I said, still in draft. I'm planning on still building it out, but if you're interested and want to take a look as it's getting built out, feel free to take a look at it. We're kind of discussing this out in the open. And also, if you have any batch cases that you think might be interesting here, I haven't added our thinking around the API. I've only added theirs at this point. So I'm hoping to flesh this out over the next day or two, and that should give a little bit more clarity.
All right, thanks. So, okay. Now we can move on to community questions, unless anyone had any last thing they wanted to add there. Any questions? Okay, so yeah, starting these two PRs.
Yeah, hopefully this question's really quick. It's just when I'm making a doc update, if you scroll down, the CI test status just stays in pending, required, expected, whatever. Is that normal? Or did I do something wrong?
I'm going to guess it's just because it's not approved to run.
Okay.
I mean, if it's just
I guess that's kind of I've never seen a
Box
CI
clear.
framework wait for approval to run before, so I guess that's probably what's confusing me.
Yeah, ours, I think it's just a setting we have in the GitHub repo that requires
Gotcha.
owner
Okay.
approval.
Okay, cool. Easy question then. So yes, that is
Mhm.
normal. Okay.
Yeah, seems to be. Is there anything else on this? Was there any feedback you guys were trying to align on, or just checking on that?
No, I think everything was reasonable. All the asks, and I tried to resolve them sufficiently. But feel free to have another look.
Okay. Yeah, and then there was also this PR.
It's the
looks-
same question for the most part, although this one hasn't received any updates for quite some time now.
Okay. Yeah, I don't know. Jonathan, it looks like you were reviewing it. I don't know, was there anything that still needed to be done here?
Yeah,
Or
I went on PTO and then I think I haven't come back to it. I'll take a look at this. I'll take a look at both the docs updates.
Awesome. Appreciate it.
Cool. Okay, then next. So it looks like Nick, you've already responded on this. You've reopened and you're going to take a look.
Yeah, this one's
So-
also slipped through the cracks and scaled out. I don't think we're not approving of it. It's just scaled out.
Okay, cool. Any other community questions? Okay, if not, I think we can probably go ahead and end a little bit early, give everyone 10 minutes back. So, yeah, thank you all.
Thanks, everyone.
Thank you all.
Thank you. Bye.